All right, hello and welcome to GLOBEBUSTERS, Season 14, Episode 19. Today, Vanby is joining us with a follow-up on his refraction presentation. He's going to be going over some demonstrations that were provided to him after his presentation by some globularist, and they are saying that this is proof of the homogeneous medium doing the lifting. Well, Vanby's got his own thoughts on that, and today we're going to learn about Vanby's thoughts. I'm joined, of course, by Shane G and Stone G. Welcome, lads.
What's up, everyone?
Yo, hey, yo, hey, yo, hey.
All right, boys, let's get refracted. Vanby, you ready?
Yeah, I'm ready.
I'm tagging you in, Coach. Let's go.
Let's do it. All right. So yeah, thank you for having me again to share some of my thoughts, like you said, some of my research, my findings. In this presentation, we are going to be examining the most commonly cited in the lab demonstrations, which are used as evidence to support the modern mainstream claims of terrestrial refraction. I will be showing a couple of my own demonstrations I did toward the end, and I will be making the argument that in all these demos I'm going to show, none are analogous, nor are they evidence of the mainstream claims. And actually, what I think they really are showing is how refraction is a geometric line of sight phenomena. And we'll get into that a bit more. But so that would mean that light from an object or image can only be refracted to your eye if you have a geometric line of sight to the object. And yeah, like I said, we'll get into that. But let's briefly establish what the claim is. So these photos here are the well-known, professionally done, extremely long-distance photos of Mount Canigou in France by Alain or Jean, I believe. It's pronounced the French guy. And so according to the modern claims of terrestrial refraction, we are told that what you're looking at here in these images is not a physical mountain. We are told that because we live on a globe with specifically known dimensions, that this mountain is far enough away from the viewer, it physically should not be visible. It should be below the geometric horizon of the globe. So what the mainstream claims is what we are actually seeing here is purely the effects of terrestrial refraction, which is the bending of light from the mountain, bending around the curve into our eyes. And I'll get into that more, but so it's just appearing to be visible. It's purely refraction effects. That's what we were told. And just a quick side note, I thought I'd just mention that when I first learned this, like a couple years ago, if even that, I spent my whole life not ever considering the distance to the geometrical horizon. And so when I first learned that we can observe things way past the geometric horizon, this is the big reason why I'm interested in learning about this, because to me that was a pretty mind-blowing thing. That's what we are told, that we're not looking at the mountains, it's just refraction, it's just light. And so
yeah, I'm thinking your story, it hits me every time, and I hear it everywhere, and it is because that is simply the number one cause for people jumping the fence, is that that horizon is not where they told you that it is, and you're seeing other stuff on the other side of it physically, and the empirical is the undebatable, and your story is the most common story, far and wide, as to why we are on or in this discussion right now, for sure, man.
Right. Yeah. Go ahead.
Sorry, I didn't answer him.
No, go ahead.
I was just going to do something different, where the discussion with the horizon has been ongoing. Like, if you ask them, is the horizon geometric or optical, right? They don't know what to do. It's like, is it physical or not? For them, it's physical because there's a certain distance to the horizon based on observer height and the radius on a sphere, using Pythagorean theorem, right? That's what drives the black swan. That's what most of our community was put forth. That's what breaks the model, is observations beyond that observable horizon. But when you ask them, is it physical? Well, it's an optical apparent refraction of a physical thing. That's the actual steelman of what they had to say, because it bounces in waves all the time. So is that physical? Is that the physical geometric Earth curve? Is that the refracted geometric Earth curve coming back up and going around? Or is it just an optical effect that changes based on other things? That's been like the main discussion think that we're putting forth. So I think this is going to hit that on the head.
Yeah, and I think when you get into the demonstrations, it really shows that it's an optical effect, and I don't think the demonstrations are rigorous enough and are actually showing what they think they are. And yeah, we'll get into that. So yeah, well, all these photos, they're beautiful. These Mount Canigou photos, they're really just one of the innumerable amount of long distance photos taken all over the world of objects, in this case mountains, that should not be visible according to the globe's geometric curve. This is a common phenomenon. It's a common types of observation that we see further than the globe geometric horizon should permit. And so these photos, you can find all these professionally done photos at the Beyond Horizons website. And they have all the documented information that we're going to be just breezing over real quick. And that's at beyondrange.wordpress.com. It's a nice little website. It's got some good stuff. A bunch of observations and pictures. But so yeah, so from that website, we have the numbers here. We have the elevation of Mount Canigou, the peak, which is 2,785 meters. We have the distance, which is just over 270 kilometers, and we have the observer's height, where the picture was taken, at 320 meters. And if you put those in your favorite Earth curve calculator, you'll find that the target hidden height is greater than the peak of Mount Canigou, well greater. So geometrically, none of the mountain should be visible. And in fact, more than 1,000 feet of the top of the mountain should be hidden from the view, according to the globe. So I got this diagram from Ruhif, and I thought it was a nice representation of what the globe claim is here. And while the observer and the mountain aren't quite to scale, it's showing their claim fairly well. So if you look at the red line here, we have the observer at the top, and this red dotted line is his geometric line of sight, and the mountain is below that. And they have these yellow lines here, and they are showing the path of light, the assumed path of light, and it's bending around the curve into the viewer's eye.
I have one small problem with the way that this diagram is laid out.
Yes.
I'm going to pin it. I'm going to pin it totally on Rue and not on you. No, do you see that big black, what appears to be a vertical line from our orientation?
Yes.
That should be perpendicular to the purple surface.
100%. Yeah.
Right? That should not be vertical. And God, it's just so hard dealing with people like him.
You're totally right.
My second question, sorry to steamroll it, man.
No, you're fine.
I'm kind of heated here when I look at these kinds of diagrams. Does he explain what each of those 6 yellow lines represents incrementally like that?
He might have an explanation for them. I'm not trying to put Ruth on blast or anything. I'm just trying. I mean, I totally hear you, and I have the same. I thought the same thing. The mountain should be perpendicular. Yeah. And but I think it still captures the claim of theirs well enough to at least be visualized.
It suggests a certain distance above the purple surface, but he's just.
Right, and so
continue, Matt. Just ignore me. I'm in the minutia.
No, you're fine.
I'm going to be.
You heard Ruhif and had to jump in. It's cool.
So yeah, what they claim is the yellow lines here are bending the light around the obstruction into the geometric view, and so it is being seen. And what they claim is that like just the top of the mountain is being viewed, and which is a whole nother presentation. I'm not going to get into like determining, because that's perspective versus amount of curvature, and so that would be that type of issue. But so they do admit that we can see at least some of the mountain, and this is how they describe it: the light bending from the mountain into our geometric field of view. And this is another really simple diagram that I got from Ruhif, but I think it visually lets the claim be known here that the globe is making. And so so the red line here is the geometric line of view. So we have the viewer as the camera, the mountain is blocking this red line, and we have our object over here on the right side. The yellow line is the light, is the assumed light path from the object to the camera. So what they're claiming is, if we don't need geometric line of sight, as it just needs to have the light be bending into our field of view. And then the angle at which it comes in is the angle we perceive it in. And so what I don't necessarily disagree with the green or the yellow line, even though this is quite dramatic. What I disagree with is that the demonstrations show that we need that to even see a refracted effect in a single homogeneous medium, you need this geometric line of sight. And that's what I think the demonstrations actually do show. But they are claiming that all you need is just the light to be bending to your eye. That's the only requirement for image formation to the globe.
There's one other thing that I need here. And
Go ahead.
I realize, I'm going to let it go immediately. This is obviously not to scale, that that's not representative of the real angles anybody's arguing here.
Yeah.
But nor are we seeing any quantification where some object twice as far away as the mountain, you're supposed to be able to see through all the atmosphere to begin with. But secondly, what kind of curvature are we talking here? And again, this is all drawn on a flat scenario.
Yeah, this is like,
if this was on a globular scenario, the yellow line would be even more bent necessarily to be able to see it. You know what I mean?
Yeah.
To put its green position where it is.
Yeah.
It would be even more required. And this is the difficulty I've got with this.
What you'll find, what I've found a lot with these demos is the scientific rigor isn't really there. So you said nothing is quantified, nothing is measured. That's what I'm going to be highlighting as we go through these demos. It's all assumed. It's all assumed. Yeah. So let's talk about the demonstrations. Demonstrations are fundamental to science and physics because they connect our abstract theoretical ideas that we have to observable reality. So without experiment and demonstration, we would be stuck in theory land with nothing to root our ideas to the physical world. So this means that what our critical analysis and conclusions of the demonstrations that we're going to look at are just as crucial as the demonstrations themselves. Understanding these demonstrations, them being analogous, them being true to the claims that we're making. And so that's what we're going to examine. So I've classified the demos that we will be discussing into three categories. We have laser demos, we have interface demos or boundary demos, which I'm calling them, where there's two mediums involved. And then the third type of demo is going to be, I'm calling hot plate or cold plate demos. And that's with a single medium where they are messing with sharp temperature gradients and
Lapse
such.
rate gradients. Yes, indeed.
Yeah. Okay, so quickly, we'll just talk about lasers first. I consider these laser demos to be really the most base level one type of demonstrations in terms of understanding terrestrial fraction and being analogous. They are pretty much not analogous to the claim that we're talking about. They are so lasers can help us visualize the bending of light, of coherent light, ray bending, but ultimately these types of demos, they're not demonstrating any sort of image formation. So we don't have an observer viewing an object. We are looking at specifically coherent light and how it behaves with and scatters within a medium for us to be able to view the beam. So it's fundamentally on its face, this is not commenting on the claim that we're discussing. And people will use this, really people who have just a really basic textbook, dare I say high school level, of understanding of this. They'll just say, they'll point to lasers in the tank. Oh, the light, we can see it bend. So therefore what? We could form images around it's, you're not commenting on the phenomena that you're trying to back the claim of. So let me look at my notes. Yeah, so in these types of demonstrations, again, we're not imaging anything. We're looking orthographically, a side view. We are observing this coherent beam. It's a coherent collimated monochromatic laser beam. And so this means that all the light from the laser is in the same phase. It's moving in the same direction. It's parallel. It's powered. And it's monochromatic. It's all one color. And so this can create, this coherent effect creates a uniform, predictable wave pattern. And as the beam travels through the medium of the water in the tank, the coherent light scatters at each point along the beam, allowing us to image it. And so I think that is one of perhaps a misconception people have when viewing lasers. They think that because they can see that each point along the beam, maybe it's commenting on image formation, but this is an effect of coherent light. This is coherent light allows the laser to be visible at each point along the beam. So they think maybe it has something to do with image formation, but it does not. The beam appears to be continuous only because of coherence and collimation. You see a laser beam in the air because they are coherent, collimated, and intense beams, which allow scattered light to be visible along the beam. We see incoherent light. So incoherent light does not produce a visible track like a laser beam. The phases and the direction of all the different light is being scattered from like a light bulb here, and it's going in all directions. It does not behave like coherent light. Sunlight, light in nature, and light bulbs like this one this is all coherent light. It's diffuse, it's weak compared to lasers, and does not produce visible rays. So terrestrial refraction, the claims we are discussing, is only concerned with incoherent light and forming images in an observer's eye or a camera, not the visibility of a single guided ray or beam. The laser tank demos do not demonstrate how refractive gradients form, shift, or reveal images. They are a ray path visualization demo. So that's kind of what I want to say about lasers, is they really just aren't commenting on the phenomena, period.
If I were going to compare them succinctly, I would say that the laser is longitudinally focused in terms of its propagation, and that a regular light bulb is radiative with equal intensity in all direction with its radiation. You know what I mean? It's not a longitudinal propagation. It's not focused. Mm-hmm. It's like you said, it's diffuse, and it radiates with the same intensity in all directions, which is why it's totally correct when you pointed out that that doesn't produce rays in the medium, because it's equal intensity. Yeah, excellent.
Okay, so now we're gonna jump to boundary refraction, and this is, I'm calling this level 2. The level 2 types of demos. This is an effect where a virtual image is formed at a physical boundary of 2 refracted medium, like we see here. Without the water, you cannot see the drain in the tank basin or in the sink basin, and then when you add the water, the drain is revealed. This is probably, from my experience in looking at demos, this is one of the most common examples used to back the claims of terrestrial refraction. This type of example is the most common, I believe, and it's also it's not analogous to the claims, and we'll get into that. But after talking to a few GLOBE proponents, it seems that this effect is kind of being misattributed and misunderstood. So I wanted to hit this home a little bit and just try to make this clear. But for GLOBE proponents, this is really as far as the conversation goes with most of them, because this demo, to them, it's all they need to satisfy their initial postulates for refraction and image formation. Because remember, like the simple diagram that we were showing, all they are claiming is that the only requirement is that the light from the object is reaching the eye of the observer. And so to them, going beyond this type of demonstration, it's unconsequential in their minds. It's meaningless. But what I'm going to argue here is that it's very consequential what they're doing. And in all the examples, a second medium is being used, which is a specific effect because of the second medium, and they're misattributing that effect for terrestrial refraction within a single medium. So I've showed a couple of these examples before. This was from Jesse Passive Light. I like this one. It's a good example. And so we have an obstructed house. It's physically, it's across the street, and it's below the line of sight. And then we're putting in a prism that is revealing the house. Here is another one. This is another type of the same effect happening. And we're looking at, we're outside a water tank, and we're looking at this little scene here. There's a car at the bottom, a red car, and we have those Legos. So this is with the water homogeneous. There's no gradient put inside this tank yet. And then this next picture, well, it is very blurry. If you can squint your eyes, you'll see that. So notice the orange here, and notice the blue rocks behind the car. The car is obstructing the orange of the Lego, the base, the orange strip, and also the rocks behind it, the blue rocks. And then once they add the density gradient, it gets really blurry. But you can now see, it looks unobstructed, the bottom of the Legos, the orange strip, and you can kind of see a little bit of space in between the car and the Legos. So they will use this as an example of the horizon lifting up. But again, this is using a second medium, and it's because that we are outside the tank looking in, and there's a boundary refractive effect of a virtual image forming. It's forming an image at the boundary of the tank in the air. So it's not analogous. It's not what would happen within a single medium. And I want to just kind of explain that really fast. There's a couple graphs I've showed before, but I want to just break this down really quick. So we are visualizing the ray here coming in from the top left. We have our two mediums. We have water and air. And as the light ray comes into from the air to the water, it bends sharply, and a image is formed at the boundary. And so when we're talking about terrestrial refraction, this is a graph of what you would expect how light to behave in a inhomogeneous single medium. Light behaves, these red lines are representing the light rays, and they are bending continuously and gradually. This is very important. They are not bending sharply. And it's that sharp bend that creates, at the boundary, that creates this virtual image. So this is not happening throughout the inhomogeneous medium. So they're introducing a secondary medium to create this virtual image. It creates a new object point because it's creating an image at the boundary. And so I have a couple of diagrams that highlight this that are kind of nice. I like this one. So we have an object in the water down here, and its light rays are coming up, and it's showing that at each point along the boundary, the images are being formed. And then the light ray bends abruptly, and now we perceive a virtual image because of this boundary. And it's essentially you're moving the object point, which is kind of the big key. You're physically putting you're not lifting the light from this object in a continuous medium to the eye. You are creating a virtual image at this point of the water meets the air, and it's an effect that creates an actual virtual image, and that is what we are imaging now. We've shifted what we are looking at, basically. Here's a couple small quick diagrams highlighting the same thing. We have the object down here. It hits a prism. It goes through the prism and comes out the other side, and now we are perceiving the virtual image that was formed. Now this is very similar to reflection and how virtual images are formed with mirrors. It's a virtual image just like a mirror, and it's caused at a discrete boundary interface, just like a mirror. So it's an effect that's happening because of the second boundary. The candle light comes in this side, same thing, goes through. Now the virtual image is formed when it abruptly changes, and we are observing the virtual image. So speaking about Mount Canigou and virtual image, I couldn't skip by the fact that I'm not going to go into this too deep, but with Mount Canigou, Mount Canigou is great because there's a bunch of topics you can go over with it, and one of them I'm not going to go in too deeply, but it's just how refracted light cannot block a light source. So when we look at the Mount Canigou images, like I showed initially, their claim was that the mountain was refracted up, and there's the sun behind it. And so we all know that refracted light cannot physically obstruct a light source. So really what they have to claim is that the sun and the mountain are refracting up together, because they can't just have the mountain refracted by itself. Refracted light cannot block a light source. So I've seen a couple examples of people trying to demonstrate a silhouette being refracted. And this was, again, Jesse Path of Light. I've seen a couple other from different channels as well, and they do the same exact thing, is where they've created this silhouette. They got a light source, then they obstruct it, so that this is behind this now. And then what they do is they put in a prism, just like I was explaining before. They put a prism, and it creates this virtual image. So it's refracting both the light and the mountain up at the same time, and it's creating that virtual image at the boundary. This is not an effect that would happen within a single medium. And so that's the huge point with this this line of argumentation, is it's just not analogous. They're hijacking an effect, a known effect at a boundary, and they're applying it to terrestrial refraction, which is refraction within a single medium. So that is image formation at the boundary. And now we're going to go into our last one. And these are the types of refraction demos that I call hot plates or cold plates. It's where again, they're messing with the density, the temperature gradient, which is causing a density gradient in the air. And in my opinion, these are the most analogous out of the three, because we are imaging something, and we are now within a single medium. So that's good. We're not introducing second mediums, and we're not just looking at a laser. We're imaging something now. But what I want to point out with some of these demos like this one, some people may recognize this type of demo, is with the liquid butane here, is that these are very dubious. They're like Stone was saying earlier, they aren't measuring anything, they aren't quantifying anything, and they are actually misattributing effect of perspective, which I will get into. But so most of the time, when you look up refraction within a single medium, like hot plate demos, and you look for papers, you look for physics papers on these things, most of them, or if not all of them, the published ones, they're not trying to bend something around an obstruction. They're doing something like this, which is neat. You know, this is over a hot plate with a gradient, and they are observing a shift of the image. But what they're not doing is bending it around an obstruction. So that's what we're focusing on, is the demonstrations within a single medium where they're trying to bend something from behind an obstruction. And so what I want to do, I want to show, there's like 3 quick ones I want to show of this type of demonstration. And I'm going to kind of talk about, as we go through them, I just want to describe what's going on. And then I want to show, after that, I want to tell you what I think is going on, and then show my demos that I did to mimic the same thing. And so the first thing before I play this is note how no measurements are taken, nothing is quantified, and geometric obstruction in all of these were never established. So what we have here is we have a dude standing on his driveway. Let me actually, I want to stop this. 1 second, sorry. Okay, somehow I got to stop. So I need to back out because okay, there we go. I wanted to get to the beginning. So we have a guy standing on his driveway. I think he doesn't show his setup, but I think he's standing up high and he's looking down his driveway, which is slightly sloped, and he's looking at this object here. And he has this weird little contraption set up with the different colors. So here, I'm having trouble pausing it. So here, he can see he's lowering it down, so he optically has blocked the color. Okay, that's all he's done. He has not measured geometric obstruction, but he has just optically blocked it. Now, I should have shown this. It's not too important, but if you look really closely, I did a pixel color analysis. I forgot to introduce this. I don't think it's as important, but you can see a little bit of red and yellow here, and the pixel analysis shows it. So that's kind of interesting that you start to notice that. And the reason I call these dubious is because they're playing with optics. They're playing with your perspective on a very minute level. And so it's easy to think that what's actually happening here is it's geometrically obstructing that red and yellow area. But I actually don't think it is. And I will explain exactly why as we go forward. So what he's done is he's poured the water now. It's a really hot day. It's probably like 90 degrees or plus out, I think he said in the video. And in the comments, by the way, because someone asked him. But so he's pouring water down, and it's changing the gradient, temperature gradient, just above the surface of this obstruction. And what's happening is it's refraction is occurring, and it's bending the already geometrical permissible rays into our view. But what he thinks it's showing is that it's lifting this image from behind the obstruction. But again, no geometric obstruction was ever established. So that's number one. And then I want to go to another one here. This was by the same guy. I forgot to mention his name. It's TJ Weiss on YouTube. And I'll have this in my notes, his exact channel. But here is an interesting one where it's, again, we have a setup, we have a camera. We don't know the heights or angles to any of this stuff. He didn't show it. Nothing is measured geometrically or obstructed geometrically. And it just looks like it is. And I know to a normal person who hasn't looked into this, it seems very convincing. Because as we go on here, he's optically just barely getting it right at that level where the red just disappears optically. And then he's got a candle behind this obstruction. He put a little box there to, I think, help focus the heat. And you can start to see a little bit of the red, which is what the target object we are observing here. And you can just start to see right in the middle. Then he puts a capping layer of some plastic, and it's more pronounced. And so again, to them, there's multiple things wrong or not analogous to the curvature or to the claims of terrestrial refraction here. But most importantly, what they think happening is that this image of the red is actually being lifted. And I'm going to show that I think it's actually geometrically visible. It's just the perspective and the information loss that's happening at such a minute scale is causing you to optically be obstructed. And then we will do one more, which is this one is the pretty well-known one. And this is where he poured liquid butane on the propane tank to cause the refraction. And so notice this setup as we go. we have in the back, we have this tall canister with clay on it. Again, nothing is measured or described. We have it, it's sitting on a cooler. They're on a bench. And then down here is a propane tank, which is obviously shorter than the cooler and the canister. And then he moves the camera over here and we squat down. So we are at an angle here toward this. And he is geometric, or he is optically obstructed the red, but we haven't measured anything. And I'll just let this go so we can see. And this is a big one. People think this really proves that, and like I said, it's dubious. It's very kind of convincing. But at first, I thought, when I first saw this, and I didn't have any context, I thought this was like a second medium refraction, you know, like the last level 2 demonstrations I was showing with the prisms. But what I actually think, so he's pouring liquid butane on this pipe, and the butane instantly evaporates. And it causes the pipe to get really cold. And so there's a temperature gradient in the air happening, a cold temperature gradient. And so I made a really simple little diagram of kind of what I think's going on here. And let me back out so we can see that better. So here's this diagram we just looked at. We have the clay up top on the cylinder. And we have the propane tank here, and the camera's been lowered down. And like I said, they think they're lifting something. I think it's actually visible, just optically being obstructed. And so to highlight this, I'm going to give some examples of perspective and how information loss happens the lower the observer gets to the ground. To the surface. And so because the camera was at a tilt, we can kind of tilt this and imagine this as he's making this propane tank his new horizon. And because we're getting into we're trying to get the camera just over the top of this propane tank, just barely, so it's optically obstructing this. And so effectively our viewer height from the surface, we're getting it as close as we can to the surface. This is effectively what's happening. And so perspective is still apparent. And so we know that the lower the observer height gets to the surface, that we start to lose information in the distance, and the apparent horizon gets closer to us. This is what this it's a little blurry here, but this is this hallway demonstration. Anyone can do this. You know, this is very simple. Perspective is where the lower you get, it starts higher on the left side. In the middle, he's getting lower, and our horizon starts to creep up, and you start to lose information. This is a really good example. This is over a lake, and we have the camera's just over the lake, and the debris is on the water at the edge on the other side. It's not too far, so there should be no real geometric globe curvature happening here. And so at 2 feet high observer, we can see the debris across the lake. And then when we lower the observer height to 0.5 inches, the debris starts to disappear. It vanishes. And then you can also take note of the lower debris, which is in the water, and it compresses upward. So everything is quickly compressing, and we are losing information. Again, this debris here that disappeared, it's still geometrically permissible. The rays from it, it's not physically blocked by anything. It is just optically we are losing the information at the distance as we lower our height. This is a quick video. I got to reset here. I got this from Shane's last presentation. I thought this was a really good, just a simple example. This guy put a light 2 inches over the water on the other side of the lake, and he has his camera in the water. So we are level, we are water level, and the don't need the sound. And he's just lowering the camera level, and the light is being obstructed by perspective.
Whoa, you guys see the Earth curve pop up out of there? Look, there it is, Earth curve again. Boy.
Yeah, this is a great example. I mean, this is perspective happening. This is just how it works. We start to lose information as the lower we get to the surface. And here's a quick little diagram, which I think can help a little bit. Notice how on the left side here, the observer is higher. He's standing higher. And as it moves to the right, the observer is getting lower to the ground. And this diagram is representing the light rays and how we perceive them, our perspective. And notice how the bottom half is getting compressed. This is because we're closer to the ground. We get lower and lower. All this information back here is getting lost. It's getting compressed, and eventually, because of the mechanics and of our eyeballs and the physical dimensions of our eyeballs, we can only resolve certain angular resolutions. And so we just start to have that apparent horizon creep up the lower we get. Information gets lost. And so
if you can go back for a second.
Yeah.
So the one on the left, that's what the Globers say perspective is all the time, under all circumstances, regardless of anything. They will never acknowledge the height difference in changing the angle of compression and the rate at which the angle is compressed. That's very important, because they say, nah, according to perspective, it'll just disappear until nothing as it goes, into it. And that's true if you were exactly in the middle of the top and bottom boxes, but that's almost never the case. So I think
we never are like that. Yeah,
exactly.
Mm-hmm. Yeah, we're always way closer to the ground, and therefore the ground is going to start. We're going to start losing information very quickly the lower we get to the ground. So now I want to show my demonstrations that I did. I recreated what they did, and in this one, I didn't take any measurements. I didn't measure a thing. I just was trying to recreate what they did. So I'm lowering my camera. I'm optically obstructing this red salt shaker here. And then I'm going to spray a little liquid butane. Eventually. Did I pause it? No, it's going. Yeah, it's going. Sprayed it, and you can see the red. I didn't get quite as a pronounced effect as they did, but there you go. So I did a couple other tests. So here's one where, again, I didn't measure anything in this one yet. I haven't measured anything. I am just trying to show different ways you can show the same phenomena. And this way, I put a little magnet on. I have an olive jar here, and I obstructed it just ever so slightly, and I'm doing it optically. And then I'm going to spray a little butane. And keep note, the magnet is way closer. The effect can be controlled a lot more when you have the object you're looking at far away. So notice how the magnet doesn't come up. We don't see any magnet. So, okay, that's interesting. I mean, it would almost seem more analogous to want to have the object you're trying to show lifting be attached to this surface, not way off in the distance. But I mean, so anyways, this is just showing, okay, I did it another way. I didn't get the effect, okay? And then I decided to do it where I geometrically obstructed it. Oops, it was going too fast. So this is my little setup I had. And, it's in slideshow mode or some shit, okay. And so what I did is I leveled the camera. The table was level. I measured the height of the camera lens right in the center. I measured the obstruction, and I measured the object that we're observing. And this was my measurements. So I got the camera height to 3.5 inches. I got the obstruction, the green cylinder, to 3.5 inches. And the target object I made 3.25 inches. And then I had the distances. We had 8 inches from the camera to the obstruction, and then 15 inches here. So I've geometrically obstructed this object. And then this is what you get when you geometrically obstruct it. So I show the object there. I spray it, don't get anything. So to me, like, I'm not gonna say that, you know, I did the most rigorous scientific experiment there or anything. All I did was just apply a teeny bit of measurements and just some measurements. All I did was I tried to geometrically obstruct the object. And what you get is you do not get the same effect. This is showing that when you actually try to geometrically obstruct something, you don't get the lifting. And so there is, for this experiment to have any validity, we need to have, and for anyone who believes in the globe to think this is proof, or, you know, that the other one where it shows the lifting, if you think that's proof of terrestrial refraction, you need to understand that there was no scientific rigor put into that experiment. You know, there was no measurements done. So, and it's ignoring perspective completely. And so while some people may have trouble understanding that things can get obstructed optically and not geometrically, then I can understand the confusion. But once you understand that, you know that these types of demonstrations that they show terrestrial refraction, examples of it, they're not analogous. They're misattributing effects. They are misunderstanding what they're doing, and they're not applying any rigor to the demonstrations that they're providing. So that is really my claim to all of this, and I think I can just wrap it up there.
Fantastic.
Nice.
Yes, I was really enjoying your depth of analysis, talking about the analysis of the VO frame in terms of how much red is diffusing through, just being a spectral. That's right on, man.
Yeah. It's kind of fun messing with refraction.
Isn't it though? Just being in the lab doing stuff and replicating and setting up the conditions, and yeah, that is what it is about. Absolutely.
But yeah, like I wouldn't claim this to be any sort of definitive thing, but you know what you have to understand is if you're a glober and you believe that these demonstrations are showing the effect that you claim, I mean, you need to be able to explain some of these things or understand what is analogous. And I find it frankly pretty bizarre that we are at a point where we don't have, like, when I went into this, I expected to get some good demonstrations, and you don't. There aren't any. Like I'm waiting. I'm still waiting. I would love to see, but the fact that people buy it without having seen or understanding the current demos we have, it's kind of confusing. You know, we don't have an analogous demo, so why are we believing that this mountain is not there?
I share your angst. It is truly about getting the empirical data with realistic modeling, and yeah, you're right. They are at a loss for trying to provide that.
Dude, awesome Prezi Vanby. And I've never really thought about the Canigoo thing, but yeah, for the globe, they don't predict the mountain should even be visible there. It should just be the sun setting. It's so weird to think about what they actually predict and like what we see, and like trying to visualize what their actual position is. That's crazy. So they have to bring up the whole thing, even though geometrically that mountain would be like tilted away from you. There would be no reason for it to be lifted up perpendicular, just straight up or straight vertically up like that. Dude, that's insane. And if you see there, Sten, I had a question for you. You see how there's red between the mountain and the shadow there, and like in the ground, like it looks like it's kind of miraging the red sun layer. Is that not evidence that the sun is still above the mountains because of the way that it's miraging in the front? You see what I'm saying? You're muted.
Yeah, I see what you're saying. I'm
I
not
think Stone
100%.
froze.
Yeah, yeah. That very well could be. Yeah, because how is it? Yeah, how is it in front of the mountain? There's some miraging effect going on. It does look like that. Yeah, definitely.
Yeah. Yeah. And then, so anyway, I just had a question about that. Maybe Stone can come back with that. I'm not super familiar with how all that works, but I thought that was a interesting little thing that's added onto it there, because it makes it look like the mountain's levitating above it, but it's just that the sun is still above it and the the rays are, causing that
Hmm.
mirage. But anyway, there was, let's see
Well,
here.
that kind of confusion is the reason that I tend to stay away from all horizontal types of observation, especially over water. That you're just inviting so many unknown variables. You cannot measure the lapse rates between here and the mountain. It's about knowing the humidity changes, the temperature changes at the surface all the way up across the image, between you and the target. And that's something that Taylor is really doing an awesome job in getting her, 3 mile, etc. Measurements taken with theodolite. That she's also got meters in between and checking lapse rate between, so that you can fully quantify what you're seeing, and then you know why you're seeing what you're seeing and which cause is really truly the cause, or which ones belong as a part of a composite set of causes. It's something you can't do with this kind of observation because it's so far away. It's absolutely horizontal. It invites a lot of argument, and it's really hard to get a hold of a proper empirical set of data for something like this.
Nice, thank you. Let's see. So the geometric line of sight versus geometric obstruction and optical obstruction, kind of giving like an apparent line of sight. I thought that was a really good introduction into your thoughts on how objects are being lifted in the way that they show in the demonstrations. So when we were talking the other day, and he showed that, when it's actually but when the object that's being lifted up is actually geometrically above the object occluding it, then you don't get or that's the only scenario where you get that lifting. And then the scenario where it's geometrically under the object occluding it, you get nothing. That's profound.
Yeah, I mean, I think the key point is like the key point is nothing is being geometrically obstructed, and like that's the key point. And because like on the driveway demo I did where they poured the water, I think he's angled down. You know what I mean? I think. Well, I actually don't know because he doesn't even show his complete setup. But the angling is dubious in my opinion. But I think the most important thing is just that there is no geometric obstruction being established. Nothing is measured. So you can play. You're playing with perspective. That's what those demonstrations are doing. You're playing with the most minute amount of perspective you can by getting your line of sight just over that propane tank as close as you can. Basically, you're an ant. You're becoming an ant on the surface of that propane tank. Essentially, you're turning your sight line into that.
Excellent analysis. And as far as your final replication attempt goes, I think in trying to get the effect, to achieve the effect that we saw in the guy with the propane tank, is I can see two variables you want to manipulate there. One is the diameter of the obstruction, like the actual distance of the chord through which the obstruction geometrically exists. That if it's really sharp, then you're only causing a very small area to be cold. But if it's a really large diameter, then you can affect a larger area to be cold at one time, and a larger place upon which all of this butane will be sitting while it's boiling and evaporating. And I think that is what you were, or he was, effectively shooting through was
Right.
the dancing fluid turning to gas, sitting there for a couple of seconds, that was, say, you know, 1/2 to 3/4 of an inch thick even on top of it in terms of its own layer sitting there. Convection will just drive it to go down, right? Everything, all the air around it is far warmer. So it'll almost be like a convective cell in itself. Those would be the two variables. Find a can of something that just drips out butane, but not at a really high flow rate, if you know what I mean. Not a high pressure rate, but
I
a
know what you're
lot
saying.
of it. So you're not pushing it away as you're dropping it onto the surface. So you can accumulate more into a larger area, and you would probably achieve the effect.
Yeah, and I also noticed by doing, when I used the magnet that was attached to the obstruction, the can, and then compared to when you put the obstruction in the distance, when you put something further back, you actually have more perspective to play off, because there's more drop off happening the further you go away. So you can create that lifting effect that they think is going on, when all you're doing is optically obstructing it, and then those rays are still geometrically permissible. They just are information loss because of perspective. So you're just redirecting those geometrically permissible rays with refraction. There's no lifting actually happening, like physical. It's just the rays of already something that is already visible to you. Yeah.
Indeed. Further to that the farther away the target or the obstructed object is from the obstruction, the less analogous the example becomes to an Earth surface. Because you're talking like you did with the magnet, that it was in close proximity to the surface and rotating with the surface, etc., in terms of its obstructional angle and falling away like the mountain doesn't show in Roof's diagram, etc. Yeah, exactly like that. That the farther away that object is, the less we're talking about what we're actually looking at in reality.
Yep. Very true.
This was great, dude. I love that we all use Life is Short. Like, he's the expert on vision. He put out like a host of videos 6 years ago, and no one paid him any attention. Lead the groundwork, foundational.
Yeah, I'm gonna put. I have a PDF with all these images. I'm gonna give references to that, like the Life is Short guy, the perspective, and everyone I use. I'm gonna put on this, so we could put that in the description or whatever. Yeah.
Yeah, that's good practice.
Yeah.
Nice.
Another good thing that I liked was the coherent versus the incoherent light, like with the laser versus the light that we see. That was another great example breaking that down. And then the boundary refraction and the virtual image situation is extremely important, because the depth of the virtual image will be proportional to how much the light was slowed. So like in the example of water, if you say that light slows down 50% and there's an image, there's a fish or something that's 10 feet in the water, it'll appear at 5 feet, like that virtual image. So so when you were talking about that separation, or that mechanism for that image to be created, like that's all dictated by that additional medium, to do that. And so that was, you did such a good job. This was the depth in which you went into this was so good.
Good. I'm glad. Yeah, you're totally right. They're hijacking that effect. That's what I think. Because to them it's inconsequential. Like I said, they can just bend the light and then up an image forms and we're all good to go. But it's like, no, you are literally hijacking a known effect of these two mediums. How
are we doing in the chat with the questions and or comments?
Everyone is laughing at the refractionist. Now everyone's having a good time. All right. But yeah, that distinction between the two effects produced by the boundary layer versus a homogeneous medium with continuous curve. No one's ever presented that, especially not with a geometric obstruction either, which is an extremely profound and important part of this, because all of the examples that we get, you know, like you said, they're either objects that are far away from the obstruction or geometrically over the obstruction, and you only have an optical obstruction, you know, relative to the camera angle.
Yep.
So then none of those are analogous to where we live. So yeah, the Globe lads have some work to do.
Yes, they do.
Or they could just concede like we know they need to. But, you know.
Dude, never. You know what they're gonna do? Endlessly,
Never concede, never surrender, or whatever.
yeah, just endlessly make diagrams, but never have any demonstration of it, and just say, nah.
Dude, are you challenging me to go to the new sophistry heights? I accept. I will never address what just happened.
You forgot formulae.
Yeah, this
Ooh.
most likely won't change any Globers' opinions because it never does. But I just wanted to get all these. Yeah, I think it's really important to lay these types of demonstrations out, the analysis of them, because yeah, there's issues with the way they analyze them for sure and come to their conclusions, and it's really important. So
Yeah, having the distinction between these is absolutely fundamental to understanding optics and where we live and how they've been misrepresented to give the appearance that we live on a globe, and how these demonstrations are co-opted to make it, you know, to supplement their arguments, but they're not even analogous once you understand the basics.
Yep.
Well done, lad. All right, we will wrap up for the week. We'll see you guys next week. We'll be closing out for this season, and then we'll come back in a couple of months. Everything will be announced at a later date. But we'll see you guys next Sunday, same time, 3 p.m. Eastern. And then
Awesome.
tomorrow night, I'll be doing Celestial Theodolite update number 30 over on Earth Awakenings. So if you haven't participated in any celestial theodoliting, it's never, you know what they say, it's never too late to join Earth Awakenings and participate in some celestial theodoliting. And on that note, we'll have we're going to up our celestial bounty rewards tier. So we'll talk about that too on Monday. And then Tuesday will be Ether Roundtable 113. And then Friday, of course, will be the community Twitter space. So join us Friday for that.